Okay, this is project one. Some backup here. I know you had some difficulty running the project, so basically to run it, you have to make the project one your current folder. So you double click on project one, that loads the values here. To run the software, you type in guide for GUI developer and type in project one. Hit enter, and it's going to open up the GUI developer, which is opened on my other monitor here, so I'm going to drag it in. You can see that here, and then if I hit the play button, which runs the software, then it will open up the actual GUI, and which again, here it is. I'll drag it in. Okay, so here's the software, and the guidelines for the program instructions said to read in the number of layers. Basically, there's 4 layers, and the engineering properties of the layers and the thicknesses. The properties are the angles, the thickness in meters, and then your modulus data for each layer. This is actually defaulted to the properties for the problem, but these are inputs. You can change them. So if I wanted a different angle, I could type in 38 or 45 or whatever angle that I want to run. The second thing is step 3 says to compute the Q and S matrices, and also step 4 says compute the Q bar and S bar for each layer. So if I hit calculate Q bar button here, it actually calculates all the matrices, which you can now see populated here for layer 1, 2, 3, and 4, and there's the Q bar, S bar, Q, and S. At this point, basically, then it says to compute the sigma x, sigma y, and tau xy at the top and bottom of each layer. Okay, the problem gave us 2 cases, case 1 and case 2. Over here underneath the graph, I've got the results here at the table here, and here's the layer. Calculate the heights in reference to the midplane for each layer in meters. And then you have stress X, Y, and XY in gigapascals. So if I hit run case 1, it's going to populate the table, and you can see all the values that go in down there. And for this particular problem, everything's consistent throughout because they have basically only strain in the X direction, no curvature, so it's a horizontal line in all cases. So in order to plot it, literally all you have to do is just hit plot stress X. There is that value, which is 1.5111. Plot the stress for Y, which again is a horizontal line. So to explain the graph, the height is on the X axis, which runs from -4 to 4, given the 4 layers and the distances, and then the y-axis is actually the stress value in gigapascals. Okay, and then obviously if I hit the shear in the xy, because there's no curvature or stress in any other direction, the shear is actually nothing, so it's a value of 0, even though the table down shows some large exponential value for scientific notation. Is actually a value of 0, I guess. So alright, and then in order to run case 2, we're going to clear off the plots here. We'll run case 2. It recalculates the tables here at the bottom, which gives you the new values for the stress and the XY and the shear and the XY. And then to plot each one, you just basically hit plot stress X for the plot for the X. And the values here run anywhere, because the angles are all the same. It's just a linear line from 20563 to 20629, and then you can see the max and min values for each layer down here in the table. I'm going to plot the Y, so I'll clear it, plot Y. Same thing, the values from the table here become the Y segments for the thing, and I can clear that and show the shear in the XY and do the same thing. The reason it's a linear line, from what I gather, is because all the angles are the same. So if we add a new angle, let's say our first layer is actually a 30 instead of a 45, and I calculate new Q bars, rerun the case, do case 2, and then clear the plot, then we will see that there is actually some differences here between the segments, so that the min and the max don't necessarily line up in a straight linear line. They're just linear line segments. And same thing with the Y and if I do it again for the shear. So anyway, that's the project, and if I want to change any other values, I can basically just change them here, go back to a 45-degree angle. Maybe my first layer is thicker, so we'll go with a 6mm value there instead of a 2. Recalculate the Q bar, rerun the case, clear the plot, and then we end up with basically just a longer line segment because, again, the angle is the same. So anyway, that's the software. Hopefully this will help clarify it for the credit. Thank you.